So section 5.2, what we will study, we call this mean variance. You may see something might not be right, is right? We learned this already. Mean, average, variance, we learned the formula already. Why we are learning this again, right? Okay, everybody, we are learning this concept from the new environment that we are given probability distribution. Okay, so let's recall some example we have mentioned previously, right? If we toss two coins, so we have the possible outcome here. We have like head, 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 tail, tail, head, tail, tail, right? And then say if number of heads, X, that's the one we are interested, right? Then we have like this 2, 1, 1, 0. Remember, we also have the probability distribution table here, right? How do we get this table? If you remember, that is actually coming from the table we just learned, right? Okay, let's go back. Remember, here's X, here's PX. What we did is what? We kind of switched the table from here. This one here. Previously, we have X is horizontal, right? We put X 0, 1, 2, and the corresponding probability X 1 over 4, 2 over 4, and 1 over 4. So we kind of put this table from horizontal to vertical. That's the reason you see now X is 0, 1, 2, right? Let's go back. Go back here, you see X 0, 1, 2. Follow me, right? And the corresponding probability of X, right? 1 over 2, 1 over 4, 2 over 4, 1 over 4. That's what we had. Everybody? So what's happening here is in the beginning, you have 4 outcomes. Is that right? You know each possible outcome very detailed, very clear. And then after we generate this probability distribution is what? Is something that is a summarized information, right? It's not about each single outcome here. It's not. It's a summarized information. X is number of heads that we are trying to find out, right? So X 0, 1, 2, right? So we're getting like 3 cases instead of 4 cases, 4 outcomes, right? So that's the benefit. Using probability distribution, we are summarized information. Based on this summarized information, can we still calculate, for example, average, right? So previously, everybody, if you are given those information, right, out of the 4 outcome here, right, number of heads, we know that are very clear. If I'm asking you to calculate what's the average number of heads, everybody, straightforward, right? Add them together, divided by 4. That will be equal to 1. Intuitively reasonable, right? So you toss 2 coins, and the coin is half and half, right? So usually if you toss the first coin, you can consider that you got how many head? Like 1/2, right? I mean, in theory, because it's half and half breakout, right? You toss the second coin, you are getting half a coin like that. You consider that way, right? In theory, right? You add these 2 together, it's equal to what? It's equal to 1, which is intuitively reasonable. Follow me, right? So that's the calculation we have used previously if we are given each single outcome. In other words, if we know all those outcomes here, right? The question is, what if I just give you, right, the probability distribution is a summarized table here. Can you still do the calculation in terms of the average? The answer is yes. We can still calculate the average. How? Everybody? So if you care about exam, care about how do we solve the exam questions, pay some attention here. How do we calculate average based on this information, right? So we are asking x is number of heads. We are given the possibility for x equal to 0. So possibility for x to get 0 number of heads is 1/4, right? Based on that information, can you tell me what's the number of heads, right? On average, we are getting, right? So everybody, we are using one more column here, x multiply px. That one to help us calculate the average. Everybody, what do we mean by x multiply px? In this case here, we are using 0 multiplied by 1/4. So that's x multiplied by px. Follow me? So we got a 0 here. We got 1 multiplied 2/4. What do you have? 2/4, right? 2 multiplied 1/4, you got 2/4. That's the multiply coming from. Everybody? It's not that easy to study online, right? It's not really not that easy. So try to pay some attention here. Okay, so this third column here is to help us calculate average. After we calculate the multiply, right? What do we do next? We add them together. We add them together. So 0 plus 2/4 plus 2/4 is equal to what? Is equal to 1. Everybody? So that is the, on average, number of heads we are getting. You see, this one here is the same as this one, is right? It should be. Because what? Because they're coming from the same background information, right? They are all both tell us if I toss the 2 coins, right? On average, how many number of heads we are getting. The first way, we got 1. That's the one we learned before. If we are given each single outcome. The second one is what we are learning tonight. Given the probability distribution table, how do we find out the average? Everybody, that's the table, that's the calculation we just went over here, okay? In terms of a formula, if you want to see that, okay? So we say that's the average, right? We call mean, okay? We also sometimes have a notation mu as average, okay? So different notation, same meaning. Another fancy way to see the average, we call this expectation. Everybody, expectation, right? So sometimes we are using capital letter E for expectation and the corresponding X, right? So we are saying expectation of X. What's X? Those number here. They are talking about same stuff, different notation, right? In terms of formula, remember we have this summation formula, if you remember that, right? The summation formula. That is to add all 3 numbers here, we calculate summation, right? And the summation of what? Summation of each x multiply px. So each one multiply, we got this number. You multiply, got that number. Add them together. So the summation of the third column here to give us the expectation, the average. Follow me? Right? So that's the, in terms of a new formula to calculate average. Okay? New formula to calculate average. Now, other question is, how about variance? Right? Previously, we have learned the formula to calculate the variance. If you remember that one of the beautiful formula we just learned previously, right? That is based on the assumption that if you know each single outcome, right, you do that way. But right now, you are given what? You are given this table. Can we still calculate variance? The answer is yes, we can still calculate that, okay? Everybody, we are going to count down column number 4 here, okay? Column number 4 here, how do we generate that? We are using the x squared multiply px. So in that case, 0 squared multiplied by px is what? It's 0. 1 squared multiplied 2/4 is 2/4. Everybody, 2 squared, what do we have? 4, right? Multiply 1/4. We got 4/4, which is equal to 1. Okay, so this fourth column here to help us calculate variance. But be careful, everybody, a very common mistakes. I do want to pinpoint that here. Now, after we calculate this fourth column, what do we do next? So we are going to add those three numbers together, which is the same as third column, right? We add them together, but we haven't finished yet, okay? We add those numbers together and then minus the average square. Check out the formula. The formula here is you summation, right? Let me use that marker here, right? The summation sign, you follow me? That's the summation sign, is summation that the fourth column, right? X squared multiplied by px. So you summation all those numbers here, let me see, right? Summation all those fourth column, 0 plus 2 over 4 plus 1, right? You add them together, then what? You try to minus, follow me everybody, be very careful here, it's a common mistake. Minus mu square. What's the meaning of mu? If you remember, that's another way to say average, is it right? So what's the average? We just calculate. Average is equal to 1. So minus 1 square. Everybody, we add everything together, we minus 1 square, which is still 1, right? So the answer is 1 over 2. Everybody, that's the variance. That's the new formula we talk about. This is the new formula. So far, so good?
Professor?
Go ahead.
In the table, how in the fourth column, how did you get 1 for the third row?
Okay, let's check out. So in the table, how do I get in the third row? This one here?
How'd you end up getting that 1?
Yes. The formula is x squared multiplied by probability, is that right? So what's x here? This case, x is equal to 2, is that right?
I see.
What is the 2 square?
Okay, I got it.
4, is that right? And
Yes.
then multiply this corresponding probability. You got 4 over, multiply 1 over 4, which is equal to 1.
All right, got it. Thank you.
Okay. Now let's
Professor, I have a question.
go ahead.
So the summation sign kind of stumps me when I'm doing the homework. So basically it means, would it mean like x squared plus p times x minus u squared? Is that basically what it's saying? Or do you multiply?
That's right. So you try to understand, you're talking about this formula here, is that right?
Yes, and the one before it too, but
Yeah. This one here is a summation sign.
Okay.
Right? Summation sign, that means after you calculate this column, right, which is this part here, is that right?
Yes.
Yeah. Then you add them together, right? You add all those numbers together. That's the summation meaning.
Okay.
And then after you finish add them together, you minus this piece here, minus mu square.
Okay.
Okay. So the tricky part here is you only minus 1 time. You don't want to minus 3 times here. Be careful for that.
Okay.
Follow me? Because in formula, we don't have like a bracket like that. If we have like bracket like that, then you minus 3 times, right? In this case, we don't have the bracket. So in other words, the summation finish up here. So after we add them together, we simply minus the mu square, minus 1 square. That's it. That's enough. Okay?
Thank you.
No problem. Good question. Let me see. So we've finished the variance calculation. So we are counting on the fourth column here, right? Using the fourth column minus mu square. A very common mistake, I would say.
Professor?
Yeah.
Where do we get the u from?
Where do we get a u from? Yes. What is u?
It's a mean.
It's a mean. That's right. How do we get the mean?
So do we get the mean from originally only x? Only
We
the
get
x?
the mean from the third column here.
Oh, okay.
You see, we summation all those number together like that. Okay, I should use that. This one here, right? So we summation all those ones. That's what's happening in this case here, summation,
Mm-hmm.
right? So that's the mu coming from. That answer questions?
Yes, sir. And then where it says variance out of this probability, the symbol under the word variance, that's not an S, is it?
You mean sigma?
It's sigma.
Oh, it's a sigma. This one is a sigma square, that's the variance. That's the same notation we have used before, remember?
Mm-hmm. Mm-hmm.
Sigma square, like put it like that, right? A little bit. The book usually puts that a little bit shorter. I put this a little bit longer to be more clear. Okay, that's a sigma. Okay.
Well, what about the zigzag E next to it? Isn't that called sigma? That one?
That's the summation symbol.
Oh, sorry.
Summation symbol, yeah, that's a summation one. It is also called sigma, I think. Yeah, it is somehow. It's also called sigma. I can double check that if I remember correctly. Yeah. Or you can say just summation sign, right? Let's see. So that's the variance, and then if we are talking about standard deviation, everybody, right? The standard deviation is what? Is the square root of the variance, right? So we take the square root of 1/2. That is the standard deviation. All right. So that's for this case here, right? This case here, we have toss 2 coins, try to find out what's the average number of heads we are getting. What's our answer? 1, right? I toss 2 coins. On average, how many number of heads I'm getting? I'm getting 1 head, which is reasonable. Because the first coin, half. The second coin, half. Add them together, 1. Everybody? If I'm asking you if I toss 3 coins, on average, how many number of heads I'm getting? The answer will be 1.5, is that right? So each coin is like a 0.5. The first one is 0.5, the second one is also 0.5, right? The third one is also 0.5. Add them together, it is equal to 1.5. Okay? If you don't believe that, we can actually calculate, right? I think I may have the calculation. That's right. You see, everybody, this table here is the one we just learned. If I toss 3 coins, right? Previously, the table we learned is the one that put into horizontal, right? X equal to 0, 1, 2, 3. And the corresponding probability, if you remember, like 1/8, 1/8, and 3/8, 3/8, right? If you don't remember that, let me quickly go over the one we just learned. I'm talking about this probability here. Remember this one, right? So now we are putting this table from horizontal to vertical. Then we have 0, 1, 2, 3, and the corresponding probability. Okay, now, so that means if we toss the coin if we toss 3 coins, right? What's the average number of heads we are getting? What do? Everybody? We simply multiply them together. Remember? We multiply them together. We got a third column, right? 1 multiply 3/8, right? 3/8. 2 multiply 3/8, 6/8. 3 multiply 1/8, that's 3/8, right? After we got third column, what do? We add them together. We add them together. That's equal to 12/8. Everybody? 12/8 is equal to 1.5. Everybody? Is the same as what we expected. Is that right?
That's the mean. That's you, right?
Huh?
1 point. That's you, right?
That's mu. Yeah. So you can write down like mu is equal to 1.5. Or you can write down EX is equal to 1.5. Anything that's okay, because we have like several different notation. They are talking about the same stuff. Is that clear?
Yeah, so E is expectation, but it's also the
Mean.
mean.
That's right. That's right.
Yeah. And so each column is added by progressing towards the variance, which is the last column.
That's right. Yeah. So we finished the average, which is based on the third column. Now to calculate the variance, right? To calculate the variance, we have to use the fourth column here, which is coming from x squared multiplied px. So it's like 3 squared, everybody, multiply px. What do you have? It's like line or weight. Follow me? Right? 2 squared multiply px, so it's a 2 squared is a 4, multiplied by 3, so we got a 12, right? Follow me? You add them together. So you add all those numbers together, don't forget minus 1.5 square, okay? What's the 1.5? That's the average. And that will give you the variance. Everybody, I didn't have time to give you the complete solution for this piece here. I have a dot, 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 means I'm lazy. So you can try to find out what's the corresponding variance for that. So far, so good. Is that a complex, everybody? I think as long as you understand this table here, right, we are creating 2 columns. And why? Because we want to use those 2 columns we created, try to find out what's the average, right? That will be the third column. Add all those numbers together, get the average, get the mean, get the expectation, get the EX, all those different ways to say same stuff, okay? Now, fourth column is to help us calculate the variance, right? So we add all those numbers together minus the mu square. Everybody, very common mistakes, okay? So we have to minus 1 square. I see